I'm Dialog from University of Sydney. Our team have got the second place in this challenge. I will introduce the method, the bilinear graph networks for visual question answering. I have uploaded our paper on the archive. You can download and read it in details. The outline is that I will first introduce the background, then following by the bilinear graph networks. At last, the experiments, including the Ablation Study, comparison state-of-art, and the tips and tricks for the challenge. The previous BERT-like VQA models, such as McCann, ViroBERT, DFAF, they model relationship among multimodalities as a single modality by directly using the scalar dot product from BERT. We first revisit bilinear twin networks. It have two inputs. The first input Q to represent the feature of words from STM or BERT. The second input V to represent the feature of objects from object detector such as FastRSN. Then it computes G to represent the relationship between every element of Q and V. By using G, it computes the joint binding Z between Q and V for answer classification. We first reformed the BGN as graphs into two parts. In the first part, the big Z primer computes the graph GA to represent the relationship between Q and V. In the second part, the small z linear combines the joint bindings of Z primary by using GB, but it omits the relationship among Z primary. Therefore, we extend the GB into two dimensions to compute the relationship between words, which have a similar form of GA. Compared with other BERT-like models, the low-rank bilinear pooling between Q and V in G computes the graphs to minimize the difference between distributions of different modalities. And also, the element dot product between Q and V implies a better way to generate the values of multimodalities. Therefore, in our bilinear graphs, it have two parts, the image graph and the question graph. The image graph lets to build the relationship between words and objects and generate their joint bindings. The question graph updates the joint bindings in terms of words by exploring their interactions. And the right answer may be not decided at once. Therefore, we stack our networks to make the word interact with the objects as well as themselves for many times. In the ablation studies, we can see that our networks work better than the scalar dot product with different layers. Also, if given stronger question encoders such as BERT base and BERT large, our network improves a lot. In the line chart, we compared our model with different layers to BGN model on the identity sets. Based on the word number, the shallow graphs perform better on simple questions, where the deep graphs are preferred in answering complex questions. With three layers of graphs, we train our network on train and validate splits with VGN augmentation, which achieve a state-of-art. Thus, our network have two advantages. First, it have better explanations in modeling the relationship within multimodalities, and also it achieves better performance compared with our models with and without BERT. In this challenge, we improve the single model of network by using beta detector from ResNext 152 and also multi-view from another backbones. Finally, our best model is 73.97. There are also several strategies to pick the models. First, the model with counter modular work better at number questions, and also model with varied layers consistent with each other. Also, without VGN augmentation is also important for improving the final performance. By ensembling 12 73 models, we achieve 75, and also by ensembling another 72 models, we achieve the last result. For the test challenge, we achieved the performance of 76. Welcome to visit our UMTech Sydney AI Center. Thank you.